So we just experienced for the first time. We just experienced for the first time, people, our DOM, our model, our list of elements on the page that we are able to use to display stuff on the actual web page. So I misspoke there. Our list of elements in C++ in just a list, just like a JavaScript list in C++ that allows us to display content on our web page. So here we go. Love these pens. Here we go. Oh, there you go. Beautiful. And there's our web page. And I'm going to draw in blue our list in JavaScript. Our model in, sorry, not in JavaScript, in C++, sorry. In C++. Soon it will be in JavaScript, hopefully, and so we'll see. But there it is. This is going to be our list. Now, technically, we know it's an object data type. But just for our purposes of thinking like it's an ordered list down the page, everything that's added to here will show up on this web page. Here's our web page. And we get to write in the beautiful language of HTML, we get to write code, instructions that add things directly to a C++ list of elements. That's kind of amazing. And those are then auto-displayed, rendered through the layout and render engine. The layout part is going to analyze exactly how to place the elements that we list out on this particular web browser's view, particular web browser's screen, particular device. And then the pixels are going to be determined by the render engine. Actually, by the way, side note, the output of the render engine is going to be an image, a bitmap image of that particular view, that screen, pinged out to the graphics card every, I don't know, 16 milliseconds, 60 times a second. Isn't that wild? This altogether is known as Web Core. This is the core set of technologies that do the job of storing a list of elements in C++ to be loaded on the web page and then converting that list into actual pixels. We do not get to write, well, we'll see, this C++. I don't know if I want to. I get to write the beautiful HTML, which allows me to list stuff down the page in order. Think about how intuitive that is. I want to add some text to the page. I write the text. I then want to add a box below it. I get to write the name of that box in the line below in my text file. Don't ever underestimate how thoughtfully designed that is. So let's get into it. Line 1 of our HTML, people. Little do you think you were coming to the hard parts of user interface engineering to walk through some HTML. Here we go. Line 1. Why? What are we doing in our first line of HTML? What are we adding to our DOM in our first line?
Putting up some text.
So we've got what's on your mind. That's going to add to our list of elements the text as our first element. What's on your mind? Beautiful, there it is. And that's then going to automatically display what's, if I write this one more time, what's on your mind on the page. Isn't that beautiful? There it is. And now our next element in our list, hold on a second, Mark. Our next element in our list is going to add what, Phil?
Going to add an input
element. Input element. Yeah, they often call them on the DOM, the list of C++ elements, they often call it a node on the DOM. But you can sort of think of this as an element, and an element on the page. An element in our HTML code, they often call these HTML tags. I wouldn't call these then tags. These become kind of nodes. I think the term element works kind of the whole way across. Yeah, input, that's going to add an input element. I'm actually going to literally show them as almost sort of bullet points kind of listed down. And there it is. My input field. Oh, that's not very nicely drawn. And then I get to add, and this is where we get to see our next elegantly designed feature of HTML. I love all of these people in this room have been explicitly, I've been told, are mid to senior level engineers. And every one of you is like, how do we get punished with this? So But everything else we're going to do, people, in hard parts is going to carry back to this goal. Everything else we do in UI hard parts is going to try to make it as intuitive as this. So there it is, button, and look at this. If I wanted to have, so that's produced a button. Okay, that makes sense. If I wanted to have some text inside of a button on a screen visually, that's my output is going to be a button with text inside of it. How would I design my programming language, or the programming language designer, to make it as intuitive as possible to have text inside of something on the screen? Well, I'd have it that I write the text inside of button. I mean, and there it is. We let it know the button's ending with a little /, but I have text inside of a button, and so that will, on my model of the page, oh, Jesus. On my model of the page, wow, that's quite a, on my model of the page, I will have a button added, and then almost like a sort of nested, like a sub-element, our text of publish, and then that will create publish, almost thinking like a sort of sub-element, or if you were thinking about this in an array, if this were a list, it would be a sub-array within the existing array. If it were an object, you imagine it sort of be a sub-object reference from within an existing object. And that then shows up on the page accordingly. Now, what about on that same note if we wanted to divide up the page into some areas to make it easier to think about its structure and not just have one giant list of elements on the page? What if we could sort of cluster elements into subdivisions on the page? Maybe we can think about this as a subdivision of the page. Our page has got longer here. Think of a subdivision of the page. Into that, we could place some other elements. How would we do that? Well, just like above, we get to place inside of other elements, in this case a division, physically on our HTML code, in our text file, 3 elements, and they're going to show up inside of that division on the page. Now, we're not going to be able to see this division until we put content in it. It doesn't automatically have any border or anything like that, so you won't be able to see it, but it's there on the page, and on our list of elements on the page, it is also there. So we add our division. I mean, by the way, the names of these in the C++ implementation of this list may or may not correspond directly to the almost commands to create them from our HTML file. So we have our, well, what are we adding in the next line? Let's have Magic. What are we adding in the next line inside our division?
Video tag.
Video. So, well, let me think. What am I therefore adding on the DOM, Magic?
Another video.
Element or node or exactly a sort of sub-element, a video node with what information? Well, where we'll find it, which by the looks of it is going to be on our own machine, on our own computer. And it looks like it's going to be a very interesting video of carpool karaoke. How dull. And there it is, added to the list of elements with the URL. There it is, with the link to it, sorry, the exact link. And then we can add some further text in P for paragraph. There it is, P, paragraph, and that's going to have some text of, firstly, love Les Mis. Oh my goodness, this is incredibly safe. Oh, and that actually should be a bit further across. These are sub-elements of this division. So these are sub-elements of this division here. And we have another paragraph. And this one says Heart 7. And there it is. And then that's the end of our division. And that will show up on our page. I haven't half made this difficult for myself. But there it is. And then Love Les Mis. And then Heart 7. People, we have never had a more elegant solution. We have a list of elements in C++ that we get to add to by just listing out in text format what we want to have added to that list in C++, and then rely on built-in technology in web call that's going to convert that list into actual elements on the web page. What more could we ask for, people? We're going to come to thumbs in a second, but here it is. Solution, an ordered list. Technically, it's an object of page, document, technical term for the web page elements that we can add to using HTML. The order and structure is set by where we write each line of HTML. And that is such a blessing. The layout engine then works out the exact structure given the pixels or given the device type. And then the render engine produces a composite image, joins up all these elements, puts it into literally a bitmap, rasterizes it, turns it into a list of pixels, and then pings it out 60 times a second. That's it for the graphics card. People, there's my beautiful page. That's it, people. So, we are blessed to have had this semi-visual code for structure and content. Semi-visual, I'm calling it. We have our HTML code, and it produces a semi-visual. Sorry, the HTML is semi-visual. It produces a model of the page that then gets displayed on the actual pixels. We get to create an element, add its content like the 7, like the heart 7. There it is, heart 7. We get to, what was our goal number 1? Display content. And we have done it. And it's visual. We get to create the element. We get to add its content. Where to add it is determined by where it is on the HTML file itself. Look at that, folks. Right inside of the division is our video, our paragraph, and our paragraph. And right inside the division is our video, our paragraph, and our paragraph. You may be thinking, yeah, exactly, yes, exactly. Well done, everybody. It's over. We're finished. We're finished. Okay, let's talk about this for a second. Let's have thumbs. We're going to add, in a second, CSS. Only, not in a great, it's a beautiful, a really cool domain that I'd love to talk about at some point, but it is not the focus of today. We're going to add it here in a very light touch way in a moment. But we have essentially built out semi-visual code for our structure and content of our page. We're very lucky. Let's have thumbs. You lost me. I'm clear. I have clarifications. I'd love to see some clarifications. Ian's thumbs are clear. Yeah. Phil's got a clarification, potentially. And why did you have one as well? Why don't we start with whys?
Yeah. Mine was just going back to the layout engine versus the render engine. Something I've not worked with too much at that level. The render engine is what literally makes the bitmap, you're saying?
Correct. Yeah, exactly. The layout engine is going to work out how should we position if we were to shrink the window, and now what's on your mind is going to wrap its text around. How is that going to affect the layout of the page?
If not topical. Totally cool. But my understanding is the render engine is like a large chunk of the browsers, and one of the reasons why we have so few of them. Is that accurate?
Oh, interesting.
That of the Here Be Dragons code inside of...
Oh, I mean, for sure. And it's profoundly sophisticated to deal with that also across all different device types. And when you're dealing with an amount of legacy ways that you can affect what is displayed, you're, I guess, papering over cracks historically that have not all been, all while you're dealing with legacy browsers that have not papered over those cracks. So yeah, the render engines, as you say, the main render engines are all spinning off from versions from 10 years, 15 years ago, and they are not, people are not building out these render engines from scratch. And really, I think only, as you say, a small consortium of producers are actually creating these creating browsers, because it is such. We essentially built almost a full operating system within an application that was designed to display text and links, and has to work across all devices. It's quite remarkable. Mark, there was a question from the audience.
Yeah. When you rendered the text node at the top, would there be an actual node around it, like a...
Yeah, absolutely. So we'd actually have here, it would be something, I should actually have done that. That was a mistake. It would say something like, text, and then there would be what's on your mind. In practice, people, exactly how these are implemented, we can go and look in the code of the web browser's engine. And to be honest, how do we do this nowadays? Am I meant to say this? We go and search in our good old friend that gives us exact lines of code from any library or technology. We do need to go and check it every time, otherwise it will tell us completely the wrong thing. But our friend ChatGPT gives us the exact implementation of the class that produces a text node in the DOM in C++ and gives us an object within the larger object model that can store text to be displayed on the page. Yeah, Mark, go ahead.
Is the DOM fully constructed before rendering the page, or are they built simultaneously?
Oh, that's a great question. We're going to come to actually when we talk about the our own efforts at building out in JavaScript a virtual DOM, and we'll see that play out there. More?
Is WebCore your term, or is it something that's generically used in the...
Oh, this is a generically used term. Yeah, excellent. And JavaScript is where we have our JavaScript core files. And think of it, though, if you were building... These aren't like necessarily profound terms. Think of it if you're building an application and within it you have a set of features that you would give a name, but it's your sort of... You know, I like to break my app into different parts and call this part, I don't know, Will Core. It's like not... yeah, Mark, go ahead.
Is was the forgiving nature of HTML by design? There was valid HTML and invalid HTML at one point, but the browser never throws.
Oh, that's an interesting question. Is the forgiving nature of HTML by design such that we don't have any sense an error handling process or an error recording history? Let me think about it. For me, it speaks to the fact that HTML, forgiving's a good word for it, is incredibly intuitive way of displaying content on a page. However, there is probably a reason why we're going to see there's a very profound reason why we do not use it for our much of our application building, and we have to move away from it to even achieve our solution 2 of making interactive applications. That would imply maybe this HTML that I'm almost saying here is almost like a runtime. It ain't. This is not, even though we go through it line by line and produce elements, we're going to see that's a one-time thing. So yes, you could certainly imagine error handling at that moment to identify failures, you know, things that could not actually be added to the page. But also at the same time, it's indicative of the extent to which HTML is a minimal language that only allows displaying of content, or only allows adding elements to this C++ list, and that's it. We're going to see everything you think that is HTML when elements get created or not. None of that is HTML. HTML is a one-time list. It would be like, yeah, it's just literally like, you know, writing a list of elements and then saying, hey, C++, can you add those? You could totally imagine an error handling stage at that point that says, no, you can't add that. But on the flip side also, it's kind of indicative of how minimal that process is. It's, here's a list of elements, add them to the page, please. Add them to the C++ list. That's it. So in that sense, anything like error handling, these are all quite significant. These would all be quite significant additions. You know, where would that error even be displayed? I'm not entirely sure. There's no like dev tools looking at the HTML execution. Maybe you could imagine like a parser of your HTML before it's loaded into the browser that could spot syntax failings, but there's not a runtime that's executing that code. So I don't even know where the error would be displayed. The console, it could be the console, I guess, but like that's the console is rendering errors as called from JavaScript, where you are actually saying please use the console. So you see what I mean? It's like it's not clear to me where it would even be displayed because it is such a minimal but beautiful for it language. Okay, let's add one more piece, which is another object or list of elements in, this time, no, still in C++, that is for, let's do purple. It is for modeling out or listing out all of the elements and their styles. So CSS, let's make sure we describe this. CSS, which I'm sure most of you have heard about or used, allows us to determine on these elements that we've structured on the page a little bit more about how they look. And actually, it's a beautifully sophisticated language. Like, it's actually really powerful to a point of fault. We're going to realize that if we write applications, UI applications, the biggest challenge is going to turn out to be maintaining consistency between the underlying data and what the user sees. So you'd probably make sure you only have one place that you can store underlying data that describes what the user sees. Not 4, and certainly not the one that's also used for styles. And yet, actually, it's almost like the CSS team goes, the rest is not always perfect, so let's try and do it here as well. It's like that famous XKCD where they add new standards. You have a unifying standard, and now you have another standard on top of the existing ones. So I think that, so we have, CSS is going to be what allows us to make this button blue, or determine the exact pixels, location of these elements, not the overall order and structure, that's HTML, but the exact pixels. But also can actually store data, like are you displaying or are you not displaying this element? That's state, that's data. That's going to turn out to be quite tricky. For our purposes here, let's just add it in. You want to see another legacy feature of the web browser? How do we add it in? I'm sure we load it in directly, right? No. We link to it from our HTML file, which gets that element added as a... Jesus Christ. These pens are... I don't remember these pens being quite so difficult. We add that as a element here, linking to a style sheet, which is a file. And so we have to use that name there, which is a file that gives us a list of styles. And as I say, we're not dwelling particularly here on CSS, but it's a chance for us to at least see. And then each of these are... Sorry, where's my boob?
Oh, it's right
there. Oh, yeah. Thank you. So there it is. That's going to add on our DOM, our list of elements in C++, that's going to add a link to a style sheet, which is going to turn on and switch on our CSS engine. And there's the linked element. There's a linked element. There it is. There's the link element, and that's going to link to our CSS. And that is going to switch on our CSS parser that's going to read that CSS code and create in C++ as well an object, just like this. We'll think of it as a list that has 2 parts to it. The first part has a list of all the possible rules. Like, for whenever you see a button, apply a background of slate blue, and then a second part that actually fully mirrors the model of the page, all the elements. And so we'd have text, and the one we're interested in is button, that would be set with background to slate blue, and that would make our button here blue. And we're not here to dwell per se on CSS, but just to see we have another model of our web page, this one describing the styles. And this is known as the CSS object model. Object is a technical structure of this, but we can think of it as a list model representing the information to be displayed on the page. Our layout and render engine will then analyze both of these and determine what to actually display on our pixels. Goal 1, display content complete. It really is that minimal. It really is that basic. As I say, interesting, archaic, maybe design feature to have our styles loaded in a different language. Maybe not well, and then we load it in by adding it to our list of elements on the page, but this is not one that's displayed, it's just there on the list of elements. Definitely not. If you think about other places where user interfaces are built from scratch, like Swift, other development environments for building user interfaces from scratch, you ain't doing it through this kind of ad hoc joining up of pieces that were not designed for that. In fact, to be honest, that's probably why Apple said we're building a brand new programming runtime or programming development environment, Swift, to build our user interfaces. Because we probably were joining up pieces from legacy application design for the Mac that then got transferred to be using on iOS. So they said, let's start from scratch and let's build out this entire development environment from scratch. But even then, they can do it. They own the entire stack. It's Apple, they own the entire stack of development, not in web browser engineering, where each feature is owned by a different regulatory body. And over the last 30 years, each of those has changed hands. And there's been multiple different browser teams all trying to do it. So we're joining up pieces here from the start. All right. So just two simple goals. One, display content. And two, let users change it. But we're done with goal one. We're actually done. Yeah, exactly. Whoa, well done, everybody. We displayed content, data from inside our computer, and we used HTML and CSS to do it. Goal two, enable the user to interact, to tap that content, to tap publish, to tap the like of number 7 and change to 8, interact with the content they see and change it, presumably changing underlying data, otherwise it'd be inconsistent. Like otherwise I could see the number of likes goes from 7 to 8, but under the hood, how many likes are there actually changing? Okay, sounds fine, but this is where the problems begin. Now you may or may not have had this intuition, and if you don't, don't have this instinct, then good for you. But for me, when I look at a screen, when I see the number 7 as a number of likes on my tweet, and I say to myself, I've got to change that to 8 by liking my own tweet, of course. Okay, this is getting old, but getting very old. But when I do that, we just said there needs to be data changing. Otherwise, what is it to say that that number of likes has changed? I remember when I first tried to build an application when I was like 21, 22, following a tutorial, and this was just so hard for me to track. And maybe all of you didn't have this instinct, but when I'm engaging with something I see on the screen and I tap to like the number 7 and it changes to the number 8, I feel like I've just said there needs to be data changing. And I'm like, yeah, I can see it. There's a number 7 and now it's 8. I can see it. It's number 7, now it's 8. And that's a trick. That's a trick by user interface engineers to pretend that what I'm seeing is what's changing. Because what I'm actually seeing there, people, right? That's my gone pen. What I'm actually seeing there, people, is, maybe I can show it here, I guess, is, if this is like, let's be more realistic and say, no, okay, there it is, 7. That's 30 maybe, 30 little on-off lights, right? And then this is another 30. When I click 7, if I've got to change the number 7 to 8, this collection of 30 lights that I'm seeing, the pixels I'm seeing, has no knowledge that this is number 7. It has no knowledge of the number 7. And I don't know, maybe you all got this already, but like when I see the number 7 on the screen and I tap it and it changes to 8, I'm seeing my data change. What are you worried about? But actually, that would imply that 30 randomly ordered pixels, or pixels in a shape that they don't know what they are, can become 30 other ordered pixels. But these are two totally separate things. I can't add one to a shape of pixels. Now you may be like, oh yeah, obviously. But for me, when I see the number 7 and I click on it and it becomes 8, I'm confident I'm changing the data of the number 7 to 8 right there. I can see it. It's right on the screen. And I'm not wrong for thinking that, because that is our nature from like 1 year, 2 years old. The epistemic and the metaphysical, I've been practicing saying those words, are identical. The epistemic is, do I know the pen is here? I can see it. I tap it. Oh, I can see it. I know it's there. I tap it and it moves. I tap it and it moves. Right, what I see is the underlying data. It is the underlying, when I see, if I have one pen and make it 2, now I have 2 pens. I can see the 2 pens. This sounds like some, sounds like someone's raving online talk. But I can physically see the atoms, the underlying state of the world, which is where is this pen's atoms in the universe, are reasonably, maybe we wear glasses, maybe we don't, to be honest, in a deeper sense, do we really know? but what I see roughly is what I get. We learn it from like 2 years old. What I see is what I get. And the job of a user interface engineer is to try and emulate that in a world in which that is 100% not the case. What I see, the pixels on the screen, is not what I get. That what I get is under the hood in the computer stored in memory. What I see is 30 lights in a shape that change into another shape of 30 lights. I know that doesn't sound like that. Well, okay, fine. But that means there must be somewhere else in the computer, and again, maybe you all thought this, but there must be somewhere in the computer, there has to be data. There has to be somewhere stored, I don't know, likes of 7, not just so that it's consistent, but literally so that you can add 1 to it. I can't add 1 to that. I can add 1 to this. So I can run code to change. In fact, there's no way the user can change what they see, which is what we want them to be able to do, without changing some underlying state of the universe. In the real world, they're the same thing. The state of the universe is the pen's physical atoms are in this location, and when I see is the reflection of those by the epistemic, my knowledge is the same. On the computer, could not be further from the truth. The one that gets me on that one was always like, particularly games like Mario. If I tap on Mario, I know that I am moving Mario to jump up. I'm tapped Mario, Mario jumped. No. Instead, when I tap Mario, I tap an area of pixels on the screen, it sends a message to somewhere where it says height is 10 units, for example, adds 1 to it, now it's 11 units, pings back and says, please paint those pixels, you know, in this new area. But I tap Mario, Mario moved. I tap Mario, send a message saying, please change underlying state, underlying data, underlying content, the height of Mario, and then from that new information, display the pixels of Mario X number of pixels further up. May not be 1, maybe 10, maybe whatever, but yeah, there's underlying data. So yeah, I add 1 to 7, and I get 8, and now I can send a message back to display the number 8 and turn those into pixels. Maybe you all knew that. I don't know. For me, I just didn't get that. Like that is, but that means that for anything the user sees to change, there must be underlying data changing. Otherwise, how is it even changed? Pixels don't have no knowledge. They don't have any knowledge of what they are, so they can't change. Okay.
Maybe AI.
Yeah, Matchik wants to be doing the jokes. Exactly, Matchik. Yeah. Yes. Yes. That should just be. Yeah. I think maybe AI should always just be the left as an answer. Pixels do not equal data. We're trained to think so by the real world, where metaphysical and epistemic are tied together. From young age, that object permanence thing, that meme of child psychology, that like what we see is what we get, and when we move it, we still see it. That is what we're brought. And so, a UI engineer failing to do that for us would be a failure of a UI engineer. That's literally their job, to give us that fake experience. But we've got a problem. If that means data's got to change, the fact that HTML is a one-time display, we can never go back. We run through this code one time, and we never return to it. So even if there were data, number 7, okay, great. How do I ever change it? I can't. It was a one-time display. Okay, let me just run on that, right? HTML, we literally go through and grab this code one time. It is taken one time. We do not return to it. I checked. We definitely don't. This is a one-time display. I cannot get back to it, which is why that question about the error handling was like, yeah, because it's really that basic. Now, to be fair, it can still have error handling at that point, right? But it implies that it's really, really basic, but it's wonderfully intuitive for it. Okay, so HTML is one-time display of content, or sorry, put it more precisely, one-time addition of elements to the DOM. But the DOM is a list in C++ with real data. That's real data. So yeah, user can change what they see. Oh yeah. That's real data. And you know what? Users can change that data. They better be able to, because users can change what they see by taking action on the page, which, given that this is a direct description in the DOM, every single thing on here directly mirrors what's on the page, that might make sense. So let's have something written. What's on your mind? Let's say I'm writing, hi. That's what I have to write. You're very nice. Okay. That's going to immediately add to my C++ data structure, my list there. Again, people, just think of this as a JavaScript array. It just happens to be in C++. All C++ engineer is going to add there the string hi. People, I just said that what we need to do to have users see change when they take action is to store and change data, well, we're storing some data. Well, in fact, we're changing the data. That would therefore implicitly have been initially an empty string, right? And then they start writing, and now there's a string. It would be like empty string, they write that at H, now there's an H here. Then write I, now there's an I in here, in this sort of element. This would literally be an object, for example, with the property, I don't know, value and high in C++. They're changing the data stored. Problem. Well, let's see. I think it says here. Typing in the input field changes DOM data. Changes C++ data from empty string to high. However, we can't run any code ourselves on the DOM in C++. If only we could. People, if we could run code on this position in C++, oh my goodness, life would be a lot easier and also more risky all at the same time, but like a lot easier as well, because we have a full dynamic store of data here in C++ capturing all the content on the page. Unfortunately, we do not get to write any code in C++ in the browser directly. And people ask me why. It's like, I think combination, it's not unusual for applications that enable you to write code, the application that does the parsing, interpretation, and compiling or some sort of compilation stage of that code to be created in C++, right? You've got to, that's just the heavy lifting language, which you can then have other programming languages execute within. That's not unusual. But I think it is unusual for them to be so separate. I would put it also down to no one expected the web browser to be building out highly complex user interfaces with thousands of elements, thousands of pieces of interactivity. They thought it was going to be a bunch of text with a few clickable links. That's what they thought. And so they never imagined that this DOM they built in C++ being only interactable, well, initially by HTML to add stuff to it one time, was going to be a problem. To the point that you remember the first 10 years of the web browser, so maybe 95 to 2005, was all about trying to let real applications be built within it. Maybe you remember Java applets, those things you downloaded that were all Flash. These were all efforts to try to recognize, you know what, in the web browser, that this ain't a proper development environment. So let's try and develop. And then I think it was probably Steve Jobs who said, no. And so JavaScript, and that's where we've ever since had a growth of frameworks that try to work within our existing structure and make it more like a traditional application development environment for UI. So we can affect our data, change it, basically go from an empty string to a full string by typing, by the user taking action. However, we cannot run any code in C++ on that data. So it's as good as stuck. Well done, we put it in input, but I can't then display it somewhere else. I can't add an exclamation mark to it. If it were a number, I can't change the number 7 to 8. I cannot run or execute any code in C++ on that list of elements that I want to display, and I want to make dynamic. I want to make changeable the content. Can't touch it. So, goal 2, enable users to see the content, change the content they see, but problem. Step 2 is impossible with our original approach to step 1. HTML was a one-time display. Can't change that data. It was done. DOM, yes, can display data, but can't run code on it. We can't run code on it to change it. We have to use what, everybody together?
JavaScript.
Oh, yeah, nice, exactly. We have to use JavaScript to create and save content, posh name data, even posher name state. State you can think of as being, well, it's just all the same, but it's all the information about what's being displayed. It turns out, if you're in Excel and you tap a cell, right, and now double tap a cell, start writing. That has data associated with that action. The data is cell is now focused true versus when you weren't tapped on it, cell focused false. So every single thing, that's why state's probably more general term than data, but they're all the same. Data, state, and or content are all the underlying things you're trying to represent as pixels on the page. But the DOM has it, but you can't run code to change it. We have to go to JavaScript to save, create data, content, and then have the ability to run code to change it. And there ain't nowhere else we can do it in the web browser. When you write HTML, it's got little scripts that do on click or whatever. That is all handled. That is all in JavaScript. We are only able to handle dynamic data in JavaScript. So, Here we go. Data encoder changer is only available in JavaScript. We're starting to get into it. I think we have to take a wipe down break. We'll start picking up the pace after this. I don't know if we took, as I say, we'll probably do a lot of nice tightening as a first. But let's do a wipe down break. And yeah, quick 3-minute wipe down.
Sure.
Let's give a hand to our wipe down specialist. Great, let's go for it, yeah. Back. Okay, people. So we were just about to explore the world that maybe for some of us is quite familiar. For those of us who are new to JavaScript, where have you been? For those of you new to JavaScript, we're going to walk through this quite pure language. JavaScript becomes the most popular language in the world because it runs in the web browser, which is almost an operating system level of available features to it. So let's actually even draw that for a second. Let's have a little sort of schematic diagram here of the web browser. I think this would be useful to keep in this corner here for a bit. Oh, that's a very strange shape. Keep in the corner here. Okay, so the only file type we can open directly in the web browser, and actually when you open a www, wikipedia.org, whatever, page, it's loading what file type? Alexa, what's the only file type you can actually open directly in the web browser?
HTML.
HTML, exactly. So it's literally, and we're doing this mostly on our local computers, that means on our computer itself, but it's literally taking in, for example, like app.html, loading it in, and then that is being parsed, that means line by line it's being interpreted, read, figured out what it says by the HTML parser. There it is. Okay, and then that is adding to our C++ list of list. Look at that, list of elements. C++ list of elements here. This blue pen's really struggling. There's nothing like getting into flow with some pens struggling. Okay, C++. No, this really does not work, this pen.
You want the blue?
Yeah.
Is there no one?
No, maybe I'll try a different color. Try purple. But C++. Yeah, I think purple may be better. Okay, and we'll do DOM in purple. A big change. There we go. C++ list of elements. Those are added to by the HTML parser. However, HTML is also where, if we look at our HTML code there, we can add a file of JavaScript code. We always talk in Hard Parts, if you've ever watched it, about JavaScript starts running, but how? You know what? It starts running by us linking a script of JavaScript code, a file of JavaScript, in our HTML that's going to start our JavaScript engine executing. Here it is. There's our JavaScript engine. And look at this. JavaScript engine's going to have a store of data that can be changed. It's going to have a thread of execution that can thread through and execute code line by line and run code. What a dream. It's beautiful. Let's do it. But note, other than that, JavaScript's a pretty basic language. I think it's a very nice language. There's a couple of very cool things. We're going to see that JavaScript lets us have code saved in functions arbitrarily. That means without us directly influencing it ourselves, execute, run later on out of order in which they were saved or defined or stored, known as asynchronicity. Out of order. On, by the way, user actions happening. When they do that, they're going to need to have the data from when those functions were saved, defined. That's known as closure. That's our favorite feature from JavaScript, right? That's the backpack. There we go. JavaScript, though, besides that, it's pretty basic language. Saves data, runs code to change that data. Does it inside execution context. Little place MIDI store to data. That's it. It's going to become profoundly powerful, though, if we can save data, change it, and then use it maybe in the DOM in a C++ list, which we know as soon as anything's added here will be displayed as pixels on a web page. Beautiful. Note, actually, technically what's happening there is the render engine is shooting out an image of the page to the graphics card, the graphics hardware, 60 times a second. Kind of cool, right? 60 times a second. That's actually the output of the web browser's web browser. It's like throwing, funneling out an image 60 times a second to that graphics card. Okay, great. So we know then, for our purposes, we'll just keep it as like a nice web page. There it is. And that's our output. We are going to have our DOM in purple from now on, and a big change. There it is. It's our C++ list of elements. There it is. List of elements. Beautiful. The first thing we're adding here, Phil, is what element from our HTML, which is not C++. That's our HTML code. I'm probably going to just, we're going to run our HTML code first. What's the first thing it adds to our C++ list of nodes, Phil?
A script element or a script node.
Script, exactly. Script, linking to which file?
App.js.
App.js. And Phil said it better than me there, exactly. A script node, perfect. Now, that won't show anything on the page. But we know that anything that's added to the DOM will be added to the page if it's a visual element. And this is all handled by the core web files or web code of the browser. Okay, beautiful. Let's go into JavaScript. Here we go. JavaScript has it has a memory for storing data. A bit constrained here, so we'll try and keep this tight. And it has a call stack that is going to be a list of the functions that are currently executing, currently running. When we start off running JavaScript, so I'm not going to assume anything here. I know hopefully many of you have seen hard parts of JavaScript. Maybe you haven't, given that everyone here listed out their favorite courses and all said Jem Young and Steve Kinney. So thanks for that. So we know that, maybe they said as well, who knows. But we know that JavaScript is going to, when running, automatically be in the global, the whole file. So the call stack will keep track of what's running, and it's initially running all the code, which is the global. Almost think of the overall file of code as a function called global that is now running. As soon as we start running a function, it'll be added to that stack of functions being run, that list of functions being run, so that we can keep track of where we are. Okay, but let's start our very first line of JavaScript here. Let's start with, who would like to call on? Let's have John. You're up, John. What's our first line of JavaScript? What are we storing in memory? And note, people, we're storing data, and user interface engineering is all about displaying content or data and be able to change it. I'm very excited that we're storing some data that might be able to be changed. John, go ahead.
First, JavaScript interface with the post and it's setting it to the undeclared.
Oh, that sounds very fancy already. Let's, yes. So we are going to inline one, store. Go ahead, keep it simple for us, John.
So it is setting it to the hey Dan.
Yes, hey, and then a little hard for me to write hand emoji, so I'm not going to do that for long. So what are we going to do, Alexa, right after that?
Then we're going to reassign post to the string hi.
Beautiful.
With an
Reassign.
exclamation point.
Much easier for me to write. There it is. Perfect. Ah, and now things immediately get kind of interesting. We have here console log post. The value of post, Alexa, is what?
The string hi exclamation.
Beautiful. There it is. Okay. This is interesting. So the console, first thing to say, the console is not in JavaScript. Not a chance. Let's have it over here. Purple, not meaning it's in the DOM, just not in JavaScript. There it is. So that is to say, it's not in our JavaScript engine, but it is in our web browser as a whole. This is our web browser as a whole. So it actually sits as a separate feature as part of the dev tools. That somehow from JavaScript we have access to it. And we get access to it actually automatically as soon as JavaScript loads in the web browser. Its memory gets populated with a very useful object, just a regular JavaScript object by the name of console. There it is. And in it is a function, a method of the name log. That when we run it by putting parens on the end, ain't really doing all that much in JavaScript. Much more interestingly, what it's doing is it's linked out to the console. where we then, so our log here is really speaking to the console. There's actually a whole wealth of functions in here. Does anybody know any other ones? Yes, Phil, please.
Error.
Error. Good, cool. I definitely know all of these. So I'm not going to spell them just in case, you know. Okay, maybe it's error. Let's have a look. Error, possibly. Yes. Yeah, exactly. Yes. Justice, go ahead.
Table.
Table. Yes, I knew that one. Table. Well done. Brilliant. Table. Each of these, when run, ain't doing anything all that much interesting in JavaScript. Ian, you got one?
Yeah, time.
Time. Yeah, time. These are definitely all of them. Yes, Paul, please.
Dir.
Dir, exactly. I knew that one. I was recently told that one. Brilliant. All of these are all functions that when run, they are what they call technically web browser APIs. That means they're features of the web browser that we API interface with from JavaScript. Okay. What are we going to be displaying here, Alexa, on our console?
The string high exclamation.
Exactly, perfect. The string high exclamation mark. So our console is a object full of functions that are backdooring out of JavaScript into another part of the web browser. Well, this might give us a clue. I goddamn hope that we got this lovely data that we can change in JavaScript and can take that data and maybe access our C++ object known as the model of the page, the document, not just with HTML that was a one-time, very intuitive load onto this object, onto this list, but perhaps we can do it with JavaScript. And that would require that in JavaScript we had some sort of label for that feature outside of JavaScript called the DOM. Maybe the object would be called DOM. No? What's the object called? Phil?
Document.
Document, exactly. We do get automatically in JavaScript a regular old object by the name of document. And it's going to have, folk, a hidden link. Whenever you see in JavaScript hidden links out to other parts of the web browser, know that it's probably being stored as a hidden property on an object. We can't just have links out to other parts of the web browser directly stored in JavaScript. What even is that as a structure, as a way of storing stuff? We can store, what data structures can we store in JavaScript? What data formats can we store? Justice, what can we store in JavaScript?
Ones and zeros.
Yeah, wow, in JavaScript, I mean, you can definitely store the number, so numbers. Yes, what else, John?
There is objects,
Objects, perfect. Strings, arrays.
non-array.
Yeah,
Boolean.
yeah, we can have Boolean. But really, there's nowhere is there like hidden link. Nowhere is there link to outside feature. So the way we capture that always is within an object. In this case, our object stored in the label document is going to have a hidden property linking to this position in C++, where we have our list of all the elements on the page. Beautiful. And it's going to be full to the brim, or as we say in England, just so we can spread a new word, because it is a normal phrase, but it's going to be chock-a-block with... I don't want to be a cliche, I want to be a parody. But at the same time, I do want to... Raise your hand if you'd heard that word before. Chock-a-block, yeah, but it's a very normal word in England. Isn't that crazy, right? This could just be a... I might just start inventing words. One doesn't want to become a cliche or parody of oneself, but yeah. Okay, chock-a-block full of functions that when they run are going to check what's linked. Oh, it's the C++ environment, C++ runtime, in which we have a list of elements that will auto be added to the page. So it's going to link to that whenever we run a function on document like, well, there's a few. Query selector, but there's many. They are not going to do only work in JavaScript. They're also going to have a look at the hidden link, see it's a link to this model of the page, and do some work there, which is just bloody fantastic. We are going to have access to this C++ runtime from within JavaScript. Wow. Okay. So, what's it say? Data and code to change it is only available. That wasn't very professional, sorry. Data and code to change it is only available in JavaScript, a JavaScript file of code added using HTML. That's what we did, right? That little script added the JavaScript is in an entire runtime. It's got thread execution run code, memory for storing data. It can then execute that code, and it can also have functions run later asynchronously, which is really cool. We have data now, but how do we display it? It says here with WebIDL and Web Core. Let's give the details of that. So our Web Core is where our C++ list is, our model of the page. We get that bit. WebIDL. This is a standardized way of describing interacting between any features of the web browser and each other, I guess, but particularly here JavaScript. So these will list out, and we can take a look later on at some code in this format, exactly how you should expect to access an element of the DOM. So it stands for, so that's how we're able to cross between these streams of JavaScript runtime and other web browser features, other web browser features, so I guess web browser APIs technically, but say web features, via WebIDL. Stands for Interface Description Language. Very fancy standardized format for describing exactly how, for example, Query Selector is going to work. So that the team building out the DOM, or the team building out JavaScript, or the team building out console, or the team building out the web audio API, all have a standardized format for describing how you're going to be able to access their features from other parts of the web browser. And that is the Interface Description Language, the standardized format for describing how you're going to be able to access features in other parts of the web browser. So the DOM API, which describes how you're going to be able to access elements on the DOM, is described in this language. So the DOM API might literally write in English language, Query Selector will work this way, this way, this way. Its implementation in the web browser will be described via the Interface Description Language. Okay, yeah, Mark, go ahead.
How do you know what's a JavaScript built-in function versus what calls out to browser features or C++?
I guess in general you go to MDN to see. That's always the answer. But if you see in MDN it says web browser APIs, there's a huge list of them, including the DOM document, then you know it's one of those. To be honest, most of them are. Most of the things we use are. JavaScript allows you to save data, and run code on it. Some things, I believe, are somewhere in between, and timers. So when you run set timeout or set interval, there is a timer feature that is not in JavaScript. But actually, I believe it's somewhat implemented in tandem with JavaScript. But most of those features which we use, if they're saving data, they're saving directly in JavaScript memory and or executing on it. That's functions, that's operators, all the stuff you'd see in, like, honestly, hard parts, besides the asynchronous features, are features of the JavaScript engine directly. Everything else that you would see in the web browser APIs list on MDN are features in this. And do you see why JavaScript's so big? It's like a control panel for all of these features that could be almost constitute an operating system. It's not as typical right now, but the Chromium engine, which is essentially the web browser engine, is and certainly was enormously until very recently, because there could be questions about its performance in terms of building full applications and having multiple instances of Chrome running on your computer in order to operate Spotify and Slack. But all those applications used a web browser under the hood, because you basically got a full operating system and then just wrapped it up to make it look like Slack app or Atom, the old text editor everyone used. Like, they are all just under the hood, the web browser implementation. You've got a full operating system there with a language that people are all experienced writing as its control panel to access all those features. Okay, let me see if it's time for thumbs here. Let's use this accessor here. I think we can actually probably, to save us some cleaning, we can actually do it on this same whiteboard instance here. Haha, that's right. Web Core gives JavaScript access to the DOM and pixels. Its access is described by the Web Interface Description Language. We are now going to So we're getting a bit scrappy here because we are going to continue using this whiteboard, even though that's not all code on here, but there was nothing of any significance that we were doing, so hopefully it's okay. But we're going to add, before our script tag, 2 elements via HTML to our C++ list of elements known as the DOM. Okay, let's do that. So Alexa, help me out. I'm just going to get rid of our first bit here and do it right here. Oh, nice. What's our first thing then being? So this is our HTML code. It's being loaded in the parser. This is the first thing that happens. First thing that happens, and it's loading 2 elements onto this list of elements, objects in C++. Let's make it clear this is C++. It's loading 2 elements on there, C++. And I think I have to have these pointing down, but then I can't reach them. It's like this. Make it really confusing by using different colors. There you go. Okay, sweet. Tell me, Alexa, what's the first one that's going to be on our list of elements, our DOM?
An input node.
Input node, perfect, there it is, input node. I'll do little bullet points from now on to show. Next one is what, Alexa?
A div.
Div. Next one is?
Our script.
Our script, which is going to trigger or kick off our JavaScript engine running. By the way, again, what an interesting structure whereby the exact position that you add the node in HTML on the DOM, sorry, via HTML to the list of elements, determines when you start executing your associated main runtime JavaScript. What a fascinating legacy feature. Okay, now our JavaScript engine starts to execute. Into it we go. It has a global memory. It has a thread of execution, executing the code line by line. The first line we've actually sort of already seen, but Alexa is going to assign what to memory?
We're declaring our variable post
And storing it as
the string hi.
hi. Yeah, so we're being a bit naughty. We're not doing a full wipe down here, just to keep ourselves from having to do so. But, well, maybe actually, you know what? Look at that. We actually can do most of this. So we never even assigned it to hey in this new code. We just assigned it to hi. No reassignment. There it is. Hi with an exclamation mark. There it is. What a great user interface this is, people. We're not even there yet. We've got some data, though. And now, things get interesting. Okay. All right, here we go. So, we have an object available to us in JavaScript that gives us access to... By the way, I watched Jordan Klepper last night. Well, I didn't actually watch it yet, but I do 2 minutes of Daily Show. And the comments are like, why is he shouting, though? So if... And so I thought to myself, I was like, interesting. Why is he shouting, though? You can put that in the reviews. Why is he shouting, though? All right. So, interesting, right? So we have an object in JavaScript by the name of document. It has a hidden link out to the C++ runtime, specifically the position in it where we have the list of elements that are going to show up on the page. Oh, what did I do wrong, people? Alexa, as soon as I added these elements to the model of the page, what should happen via my layout and render engine?
They show up.
They show
on the
up.
page.
There they are. Exactly. That's my fault. So nothing in the div. We wouldn't even see it. Technically, it wouldn't even be that big. It sort of expands to fill with content. We wouldn't see it, but let's just have it there as a kind of, so we know it's there for our purposes. Input field into which the user can write. By the way, if they did write, would show up here on the DOM immediately, store data immediately. Okay, so here we go. This object has a hidden link to this list of elements. It has a bunch of methods available to it, 30, 40. We can go find more. We can go find all of them on MDN, or obviously now more likely, you type into ChatGPT, what are the top 10 document methods? It is what it is. To be fair, will it be correct? Probably for that question it would be correct, but not guaranteed. But yeah, that list of functions allows us to have fine-grained control. Oh, well, not even fine-grained control. Just allows us to access this list of elements in C++. That's kind of cool. It's like it's going to point in. Actually, that's technically what's going on under the hood if you're interested. It's known as a C++ pointer that's going... A C++ pointer that is a reference, a link to the exact place in the computer's memory store where this list is. Okay, So let's do it, honestly, people. Let's do our first line of I guess, harder code that's accessing this object, this list from JavaScript. Phil, left-hand side, what are we declaring?
We are declaring a constant variable called JSDiv.
JSDiv. Okay. And in general kind of quality technical communication, what is the right-hand side doing? Before we know what the query selector is going to do, what in the high level is going to be returned into JSDiv?
Yeah, so we're going to initialize it to the evaluated result
Beautiful.
of running the query selector method on
Yep.
a document object,
Beautiful.
passing in an argument of div.
Beautiful. So we're going to, I couldn't have said it better. So we are going to call, we're going to call query selector on the document object. So we're going to go look on the document object, find a method, query selector. We know we're going to try and execute, you've got parens. That means go run it. We are not saving, so be careful to say stuff like we're going to assign document query selector to JSDiv. We're going to assign the evaluated result, the output of invoking query selector. Okay, what the heck happens when we do that? Well, 3 things, people. And actually, it is 3, we can sort of walk through it one by one. Inside of query selector, 3 things are happening. 1, go look at the link under the hood, the hidden property on that object. This, by the way, is a bit like the links you've seen if you've done hard parts, square bracket, scope, for where the closure is referenced, square bracket, prototype. This hidden link is going to head out to, though in this case, this C++ list. And it's going to hit the overall list because document has a permanent link to the overall list where it's going to query, search, fancy word for search, a selector of type div. A selector is any label we can use in here to select an element. It will turn out there are other ways we can select an element via a class name or an ID, but for our sort of code here, we're going to search by what string, Phil?
Div.
Div. Perfect, there it is. Search for div in the DOM. Do we find it, Mashik?
Oh yeah, it's found.
There it is, beautiful. Okay, and I guess step 3 would be to bring back that, not that one, that div back into JavaScript so that we can then start making changes to it. Problem. Who thinks we can bring C++ objects into JavaScript? Raise a hand who believe... Oh, very excellent, exactly. Yes, Ian was scratching their head. Exactly. We absolutely cannot. So, probably you already got a little hint what's going to happen. Query selector in JavaScript is going to automatically create for us an object. Okay. This object is going to have, you can probably already guess, a link, hidden link on it. We can't console log this hidden link to that div element on the DOM. It's going to have a hidden link to it. There it is. And even better, it's going to be populated by JavaScript with the help of WebIDL that tells us how query selector with the input of div will behave. Is going to be populated with a slew of methods, functions, posh word for methods, posh word for functions when they're on an object, all of which will allow us to edit, change, remove, update, get information from this C++ object in C++ memory. All from within JavaScript. It's kind of epic. So we have a whole bunch of them, but I guess we're going to use, and therefore will only show for now, the one text content, and that will be a DOM method that's actually hitting this element out here. And that is what is assigned to JSDiv. And so actually, let's draw that on here. So this is the output of running document.querySelector called with the input of div. The output is an object. Let's draw it right here again. An object assigned to JSDiv that has a slew of useful methods on it that are actually going to go out and access via the hidden link, they're going to go out and access that div element up here. So, you know what? Let's just make sure we show that, even though it's not the prettiest thing. There it is, to that div element. Not the prettiest thing, is it? Ooh. Oh dear. Okay, beautiful. By the way, we'll see in a second, what do we think our JS div would show in our console? If we were to console log JS div, presumably we'd get this object with its methods and the hidden link. That would be nice, wouldn't it? So what do you think is going to... Well, let's at least... If it's not that, because we're console logging from JavaScript, so that would make sense. But I guess given that the most interesting part of this is the link to the DOM element, maybe it would show, you know, something like DOM element type div in C++. Maybe? Maybe. What it definitely wouldn't show was the command that we wrote in HTML to create a div. There was a one-time, like, that triangle bracket div thing, that was like a command. Now please go and make a div DOM element. The output of that command in line 2 was an object in C++ of type div. It definitely would not show in the console when we console log JS div, which is a JavaScript object with a hidden link to the output of running triangle div, triangle div. It definitely wouldn't show triangle div, would it, right?
Well, can you switch to blue? The purple's too dark.
Oh, okay.
And nobody can see it.
No way. Really?
It's difficult to see on my...
Perfect. Okay, no problem.
I mean, I can't see it at all right here.
Toss
really,
it.
but-
Toss it. We're not going to use those anymore. Just throw it. There you go. Thank you.
No problem. So, beautiful. Blue is doing really well here now. And so, what's going to show on our console? Surely, it's going to be... Oh, whatever. It is exactly... It is the command to make the DOM element in C++ that showed up on the page, even though we're console logging the object that has a hidden access to that DOM element. Could you imagine a more distortionary... I wrote misrepresentative, there we go. A more distortionary representation in the console. It's truly kind of wild, right? You know what I think it would be like? It'd be like if you were to console log... that's my console log there. The call to a function, let's say it's sum123. Let's say we had a function like that. What would that console log, Phil?
In reality,
In theory, yeah. What would it actually console log?
it would console log the evaluated result of it.
Which would be? 1 plus 2 plus 3. Everyone together? Yeah, good. I don't. No one. I mean, nobody. No, exactly. No, I wasn't. But I was like, there's nothing like asking someone a math question in, which is really just a memory question, of course, right? Isn't it? Think about that. Shower thoughts. There you go. It actually probably is, right? Math questions are really just memory questions. And like arithmetic questions. Maybe no one's really right. No one's right. No one's like, oh yeah. No one's just for online. Nobody's going. Oh wow, yeah. So you cannot log to the console a command. You can't. It's got to be a value. It's got to be the output of doing something. It's got to be doing the work. And then this is a command. This is a command. Please go and create a div element, a DOM element in C++ of type div. And then we then console log the link to that in it with its object with a bunch of methods that let us edit it. But you know what shows up when we console log it in the console? Bloody the original command from HTML. Couldn't be more distortionary. And that's just the designers of the console trying to help us. And I would say doing a great job. There we go. So let's now use the fact that the real JS div is not this that we console logged and saw, but instead is an object with a method that has access to the C++ DOM element. And so with that in mind, in line 4, here we go. We are going to access JS div. Oh, that's not very good, is it? Let me get this right. Let me get my wording right. So, here we go. What is post? Ian, what is the value of post here?
The current value is the string high
Beautiful.
exclamation mark.
Beautiful. Perfect. We are going to try to attach to, we hope, the DOM element, the string high. Well, here's already a tricky question. JSDiv is our object that has a method, has a property text content. I kept calling it a method. Maybe you can think why. Because if that were a regular old property, Ian, can you help me with this? Where would that high be assigned? If I had JSDiv.textContent equals post, which as you said is string high, where would that high be stored on that JSDiv object?
But if it was a regular old JavaScript object, then it would get stored as under the key text content in the object JSDiv.
Can we just give Ian a round of applause for really sharp communication, Ian? That's really, really good. Yeah, which is of zero use to us, right? Because now, great, now you've got a high in JavaScript. Where do we want it to go, Ian?
We probably want it to go out to the DOM.
Yeah,
and
beautiful.
by extension, show up in the UI in the browser.
Beautiful. Wow, Ian, excellent, excellent. Exactly right. We want, and it does, because in practice, text content, oh, wow, look at this. Can they see that? That's beautiful. In practice, oh, look at that. That's in practice, don't worry, it's all going to come off. No problem. There it is. In practice, text content is working to do this. One, it goes and looks at the link. In this case, it's a link to which element, Ian?
Is a link to the JSDiv.
Yeah, so JSDiv is our JavaScript label for it, which has a link to our DOM div element.
Okay.
Spot on. And then we are going to take the value of post, which is high, and we are going to set. So a property that acts by running code under the hood to go and do something else, even though it looks like a property, you can call a getter-setter property. It is, in this case, going to set the value or the text of this DOM element to be set text in C++ to be the string high from JavaScript. And now, exactly as you said, Ian, high shows up on the page. Beautiful. Flipping it. We've now managed to display content. One second, Paul. We managed to display content that would have taken us one line in HTML. Honestly, actually, we didn't even do the. Yeah, it would take one word, one letter, or three letters. We could have written hi inside of that div for it to show up on the DOM. Do we start to see why HTML is such a magically intuitive language and how JavaScript is so rough? However, it's going to give us fine-grained editing control. It's going to give us fine-grained editing control over what we can do to these elements and the ability for us to change data in JavaScript and then change what shows up on that list of C++ elements. Wouldn't it be wonderful if we could write C++ directly there and do it rather than have to access it through a bunch of slightly quirky JavaScript and create I call this an accessor object that has a hidden link to the DOM element in C++. By the way, people, especially folk online as well, you might be thinking, oh my God, do I need to know all this? Well, that's a separate question. That's a more deep question. But you might be thinking, wow, this is a heck of a lot just to put some content on the page. However, it does turn out that once we have this model down, this is the model until the end. Once we have, as I said, there are 4 parts to UI hard parts. Part 1 is the truths. Part 2, 3, and 4 are moves to make the truths more easy to work with. Yeah, it's my new quote. It is demanding. However, once we have it down, it becomes the standard. What else was I going to say about this? Yeah, so the high is set as our value on text, and that shows up automatically. I think let's have thumbs. Let's have thumbs on this. I want to start seeing clarifications. Excellent. John's got one. Justice is clear. Paul's got one. Fantastic. Phil, Alexa, Y, all clear. Let's start with Paul. You had yours first.
It's not a big deal, but you put the high in the wrong box there. You put it in the
Oh, no. Honestly, Paul, thank you. Everybody is grateful for you doing that. Thank you. Because otherwise that would have been we do a round of applause for Paul? Yeah. Thank you, Paul. Honestly, that's just, for me, that makes me appreciative of you following it so closely. Fantastic. What else I was going to say? Oh, yeah. Why do we need to even know this? Well, flipping out, we're going to see in a moment that the fact these are in two different places. Our data is in one runtime, and the structure that persists displaying that data and directly mirrors what's on the page is in an entirely different runtime that we access, by the way, on a case-by-case basis. We're going to quickly see there is no way to have data. Well, I'm not going to give it away, but wouldn't it be nice if we could have changes of data here flow directly through to here? These are two different runtimes that we're going to have to manually make the moves across to change. Because you might be like, well, do I really need to know this? Like, unfortunately, having your data in a different environment to the structure of your page where that data ends up being actually displayed, and when the user changes, the data is going to change here, but you've still got data over here, that's going to turn out to be profoundly challenging, is going to be why we impose such strict rules on ourselves to make things at least as predictable as we can make them. But also, what was I going to say? Oh yeah, but also, my goodness, the web browser doesn't half make it hard for us to realize this. When you have the console logging the HTML that created the DOM element in C++, when actually you're logging the JavaScript accessor of that. I mean, that couldn't be more misrepresentative, right? All right, John, you had one.
So I had a question about the call stack. So document.query selector is being pushed to the call stack, or?
Oh, good question. Yeah, you know, technically it is. I think the reason I'm always hesitant to put it on the call stack is it implies that, you know, it's code in JavaScript being run, right? The question, I guess, becomes, where does the JavaScript execution here end, and where does the C++ code begin? Well, these bits are going off to access C++. Don't forget, JavaScript is technically running within a browser in C++. So actually, you can think of that handling when tasks go out to other parts of the browser under the hood, and when it's actually just JavaScript code running. I don't ever put it on the call stack, although it is on the call stack, because I like to think of the stuff on the call stack as being the code that we have written and that we are taking the thread of execution inside of, and that we could actually, you know, change the code inside the functions that are on here. Whereas we can't go and change query selector. But yes, as a JavaScript function, even though it's actually doing a bunch of work outside, it technically will go on the call stack. Yeah, great question. Let's have some online ones. Yeah, go ahead, Mark.
Do all script tags refer to the same JavaScript runtime with shared memory space and etc.?
We'll see that in a moment, actually. This is the second one where we're going to come and see this. Once we start building out our own version of the DOM. So let's hold the ones around how JavaScript's runtime works across different... these are ones which become interesting. So when we think about hard parts, it's always intellectually fascinating to go deeper, right? But I do always like this kind of I don't know what the quote really means, but the turtle's all the way down quote, which is, you can always go a layer deeper. The question becomes, is it helping you understand building what you're doing, you know, today? We're not doing this for the sake of the intellectual satisfaction, although to be fair, we sort of are. Only because I want also you all to be able to go to your interviews and say to them, this is the first I'm going to let you, you're going to by the end of today, even by the end of today, maybe by tomorrow, be able to say, I prefer to spin up my own custom implementation of the virtual DOM. Let me try that again. I prefer to spin up my own custom implementation of the virtual DOM. And by the end of tomorrow, did I miss part of it? Okay, no, you can't do it yet because you don't prefer it yet, but soon you will. But soon you will. Once you do, you'll be able to say that. What I'm getting at there is this stuff is incredibly important to understand. The great UI frameworks, the Reacts, the Sveltes, the Vues, the Angulars, I should have said at the start, sorry people, under the hood, such that you can debug them, such that you can work with them at scale, such that you could even genuinely spin up your own versions of them. It's for that purpose. However, it is also quite cool to be able to go into interviews and speak to some of these things, because the senior engineers, the VPs, whatever, interviewing you, to be able to tell them these sort of things, they may have come to these over years of kind of piecing it together, But for you to be able to give them these mental models, honestly, it's a cool edge. I'm not saying you want to intimidate them. I'm trying to be polite. I don't want to have on record. I'm not saying you want to scare them, but I am saying that you want them to come away saying, uh-oh, my job is on the line. This person's knowledge is... No, I don't want to see that's not very nice. But that's the goal. No. So, in terms of the question there about JavaScript runtimes and or how between different web pages and within a web page JavaScript is executing, we'll see later on from a place of why how that works. The reason I say that is each of these pieces we want to introduce as ultimately enabling us to do something, not for the sake of just, intellectual knowledge. Okay, good. So I think we're coming to another wipe down. In a moment, we will... let's just summarize. Web core gives JavaScript access to the DOM and therefore pixels. That's not nothing. I should have said, have you ever seen in any of the Hardparts workshops us adding anything to the page, the actual page ever? Never have we done it. Because you just saw, it ain't easy to add a single piece of text. We've never touched it. However, fortunately, WebCore and with the help of WebIDL defining the DOM API or allowing DOM API to be described, we do get access. Goal 1 was to display content data to the user. With HTML, we did it in I think we dwelled on it too long, honestly, but we did it quickly. With JavaScript, it ain't so easy. But we did get to create and store changeable, mutable data. Post is high. Then we got a link to the actual DOM element, the div, via using the object document that itself has a link to the whole list of elements, where we ran the query selector method that allowed us to search this list of elements, retrieve not the actual element back into JavaScript, into JS div, because we can't copy a C++ object into JavaScript. Not possible. Instead, we created a brand new object, or JavaScript did for us with query selector's help, in JavaScript that was assigned to JS div, and that object was populated with a hidden link to that list of elements in C++. No, incorrect. To the individual element div in C++ in the DOM, and a bunch of methods in JavaScript or properties, but they do a lot more than a regular property, because as Ian rightly pointed out, a regular property would have assigned the value of high post to text content here in JavaScript on that object, but it ain't a regular object. It's a special object that has these methods ping out to set the value of the text on the C++ element in the DOM to the value of our content from JavaScript. People talk about declarative versus imperative, or I would say descriptive versus imperative, or easy versus a lot of steps. And my goodness, what do we think of JavaScript? What a wonderfully undeclarative, undescriptive, unintuitive, and we're going to spend the rest of our time. That's why the HTML is so important to value, because it was all about doing it the way that we spend the rest of our time in UI engineering trying to get back to. Describing on the page what I want to show up. Unfortunately, it was a one-time description with no changeable data. Can I get back to that with changeable data? By the way, I should say, side note, things like web components try to do that without us having to build it all out from scratch ourselves. Whether they take off fully or not, but they're all trying to solve that problem. Describe the page like we did in HTML, in ordered list down the page, but now we get changeable data. Do we get changeable data in HTML? Everybody, thumbs changeable? No, not thumbs. That's going to ruin that meaning. Do we get changeable data in HTML?
No.
Yes, exactly. No. When I do that voice, it's often yes, and so I can see it's very... Okay, use built-in property methods to add the content. I say methods because they do more than just set a local value in a key value pair, right, in an object. Instead, they send a message out to set through the link to the div element that they cross the streams. I like to do a double line down here, really, because it's between JavaScript runtime and C++ runtime. Exactly. And then DOM automatically displays the content on the page itself, known as the view, is what the user sees. Success, but so much harder than div7 div, which is what we did before. So I've got so much color on my hands here. Okay, how to technically communicate lines 2 and 3. I wanted to just make sure we sum up how to technically communicate, lines 3 and 4 here, just so we have it in reference for ourselves. Actually, anyone want to give it a go? Whew, this is going to be... Anyone want to give it a go? No, definitely not. You know what? Alexa, do you want to give it a go? Line 3, technically communicating at some level. You could do it very detailed, or you could kind of do it more short form, high level. But give me a go of what we did in line 3 there.
Yes, so in line 3, we declare our JSDiv variable, and then assign to it the evaluated result of running our query selector method on our document object.
Beautiful.
With the input, the string div.
Beautiful. And that result is going to be what?
A JavaScript object.
Right. There it is.
With that link
Right.
to that DOM element that we queried for.
Right, which in this case was we only query selector. We'd have to check the rules in MDN, but it gives us back a link to the first element of that type that it finds. Not a list of all of them, not the last, but the first. Okay, yeah.
Mm-hmm. So we have a link to there, and then...
By the way, that would be good enough. That technical communication would be good enough. That's it. That's what it does. Maybe you want to add a bit more?
Yeah, in that JavaScript object, we also have all of those getter-setter
Properties or methods, yeah.
that go with a div.
Wow. Let's give a hand. Awesome. Excellent. Exactly. Beautiful. Who wants to take a shot then at line 4? High bar to follow. Ian, you want to take a shot at line 4?
Yeah. So...
And it's okay, by the way, if you're not perfectly precise on this. That is the point, because it's going to allow us to clarify the edges of this. So, yeah, Ian.
So we have the element reference, or the JavaScript object
Yes.
that represents the element.
I like that. That represents or has a hidden link. Yes, represents or... Yes?
And
Under what label?
we're accessing the property on it text content.
Yes.
And assigning it to post.
So even
But
that,
with
I get
the
a bit...
knowledge we have,
I get a bit nervous about assigning it to post.
with the knowledge we have, we know it's not just an assignment, because syntactically it looks like it's just an assignment.
Correct.
But under the hood, it's actually calling the setter method to set it to the value of post.
Set what to the value of post?
It is setting the text content of that element,
In
the node,
In-
the DOM,
in which language? In which runtime?
in the C++.
Excellent. Let's give Ian a huge hand as well. Beautiful. Flipping heck. I don't want to make comments about you being a fellow ginger as well, but I think it's important for the people to know. No, that's not good. All right, that's not good. All right, that was a mistake, but good job, Ian. All right, people. So I think we're now coming to, so we are now almost there. Before lunch, we are going to finish building out a full piece of user interface. Knowing that, right now you've only done half of it. Step 1, goal 1 was to translate data to be displayed on the page. Not even translate, to display content. It was very easy with HTML and a real pain already with JavaScript, although excellent communication from Alexa and Ian about what was happening. We just saw it. We do now need to enable... Oh, I probably... is that, so, yeah, we do now need to solve for goal 2, where users can change what they see. I never should have a slide up before we reach it. Users can change what they are now seeing, which was the text hi, via some action that they take. Display content, let users change that content. I like to say change that content because that implies some sort of ambiguity between are we changing what they're seeing or the underlying, and probably that's going to be the crux of our challenge. But it's the ability to change that content. So we're going to somehow need to enable users to act here, take action. I'm going to start, writing a list here of user actions that they've taken. For example, type, I don't know, Y. It's fantastic we have someone with I know it's not your full name, but one of our audience members is Y here. Type Y, and that will then update the value of the input on the DOM, and somehow that will communicate into JavaScript. Data has changed. Because there's no use having it. If we type Y, it shows up here. It'll show up immediately as a value on that input here in the DOM. If we could write code directly here, beautiful. We can't. Data exists over here, and data needs to be changed over here. And if you want to change it, that changing could be adding an exclamation mark. That changing it could be displaying it somewhere else on the page. All of that requires By the way, wouldn't it be awesome if you could just say, oh, just display it here? They're literally probably right adjacent to each other in computer memory. They literally might be like, in the same position +1 in computer memory. But it's going to turn out, people, we do not have any ability to pass the data from the input field to the adjacent div here in the DOM. Instead, we're going to somehow need to have the DOM trigger lead to some code running back in JavaScript that could go and get that value of y, maybe even save it here in JavaScript, and then attach, like we just did, to that div that value of y. It's not, yeah, it's not, this is the legacy application development environment that is the web browser. This is why we have 1,000 frameworks to try to make this is with one piece of UI, one tiny piece of content being displayed that is going to be interactive. It's going to be our code here. We'll see this right after this break. We're going to wipe down, but we're going to be able to access both our input and our div. We're going to attach a function that will handle the user typing something into the input field. We will then grab our data, put it into JavaScript, and then use it to re-update our data in C++ and therefore display it on the screen. All right, wipe down period, people. So 3 minutes while we wipe down, and maybe I can wash my hands. It's fine. I like I'm at a children's birthday.
Yeah, it's time for lunch.
Time for lunch?
Yes.
Okay. Sweet.
So, back in about
12:30 already.
45.
Yeah, we could do